Hello, Jamf Nation. Welcome to session about binary insight, opening up Jamf threat labs, scanning to customers. And please give a warm welcome to Nick Benyo.
Is that better? All right. Thank you for your patience. Got the forward-looking statement disclaimer. You've probably seen these at many of the Jamf talks. I'll give you about 15 seconds to digest that, and then we will go ahead and get started. All right, let's go ahead and get started. So good afternoon, Jamf Nation. Welcome to Binary Insight, opening up Jamf Threat Lab scanning to customers. So today, I'm going to take you on a journey that started with a massive bottleneck and ended with something that we are proud to offer as sort of an early access service to people who might be interested. My name is Nick Benyo. I am a solutions architect at Jamf. I have been with the Threat Labs team for almost 3 years, focusing on keeping Mac users safe from the ever-evolving threat landscape. Before we dive into the solution, I do kind of want to introduce you to the brains behind all of the definitions and research that power this tool in Jamf Protect. So Jaron Bradley is the director of Jamf Threat Labs and undisputed authority, in my opinion, on macOS threat hunting. This isn't just another security expert. He's the guy who literally wrote the book on Mac security twice. His first book, OS X Incident Response, became a go-to manual for forensic investigators. And his brand new 2025 release, Threat Hunting macOS, Mastering Endpoint Security, is available next week. But if you stop by the Threat Labs booth, he has a copy of the book on display. He has assembled a team of ultra Mac security researchers, many of whom you already know. Ferda Seljuki is listed right there. He's our staff threat researcher, and he is constantly publishing new findings on nation-state actors. We have Alan Goldbig and Tice Chauflair. They're well known in the Mac community and bring an admin perspective to security that is indispensable. And lastly, certainly not least, Maggie Zernhelt is a threat researcher with hands-on Protect extension development experience and has already published multiple findings. So now that you know a little bit about the team of researchers behind Threat Labs, which will be important as we talk about this tool, we can launch into kind of how it all came about. So 1 day, 22 hours, 6 minutes, and 32 seconds was the last time that I checked to get the exact number. That's not how long it takes to drive from here to Florida. That is how long it was taking for us to scan our entire corpus of binaries on a third-party platform. So this was a 44-hour problem. And it became really important because anytime we updated our Yara rules, which are these rule-based detections that we're using to scan binaries, we needed to rescan our corpus to ensure that we were maintaining and optimizing protections for Jamf Protect. In short, every change to Yara requires a rescan of the whole corpus in the process that we were following. Now, by the time we got the results back, we had already moved on to the next version of Yara in some cases, and the previous scan was out of date. So this wasn't just inconvenient, this was creating a sort of a traffic jam. There was a building queue. Does this look familiar to anyone? I'm from Seattle, Washington. If you've been on I-5, it's just this, just like every day. This is what was happening with our scanning queue, except instead of cars, there were hundreds of thousands of binaries waiting to be analyzed. So every hour that passed, the backlog grew larger, we'd clear some samples, and it would get to the point where the next scan would be queued up for us to rescan everything. It was kind of like trying to drain a bathtub that had a faucet that was running faster than the drain. So, what were we going to do about it? I don't know if anyone has seen this quote or knows this quote before. Three great virtues of the programmer are laziness, impatience, and hubris. It's Larry Wall, creator of Perl, who said that. We certainly were impatient with our existing process. We were too lazy to keep managing workarounds, which we had tried multiple times. And yes, we had more than enough hubris to think that we could just build another solution that would fix it. So we stepped back, and we really analyzed the problem. We had hundreds of thousands of binaries to scan, and each scan is completely atomic. Analyzing one binary has nothing to do with analyzing another. They're all independent operations. Yet our existing process had them all queuing up, trying to squeeze them through a single server one at a time in this queue. Now, I don't know if anyone knows what type of parallel problem this is, but it's a common one. It's called an embarrassingly parallel problem. And it's embarrassingly parallel because these problems are very easy to divide into independent tasks. It's embarrassing not to parallelize them. So internally, we're basically using an MPP architecture to be able to solve this. We're spinning up a bunch of different environments. They're not really any queues, and we're just dividing up the hundreds of thousands of binaries amongst those different processes, and then we're scanning them all at once. And so we turned a traffic jam into a 100-lane highway. So remember that 44-hour problem? 90 seconds was what we got it down to, okay? And so that's an 1,100, X improvement. So what used to almost take 2 days is now running in a minute and a half. But here's the thing. We realized, okay, this is actually running pretty well. This is pretty performant. And maybe we've got enough capacity that we can share this scanning. Before we get into that, what we came up with a way to share this, to open it up to you so that you're able to scan binaries without having to detonate something on an endpoint that you're running Protect on. Let's talk just a little bit about the architecture so you can kind of understand what we're doing here. So we deployed this service into the cloud. It sits behind a load balancer. It's got multiple availability zones. It's resilient to data center outages. And when Protect's version updates, we have an event-based architecture and a caching layer that's set up that allows us to be able to update to those newest versions within a couple of seconds of the update to the Protect version. So what does this mean for you? What do you get out of this? The Threat Labs macOS binary scanning service will give you on-demand scanning. So a developer wants to deploy a new tool, you can scan it first. You found something suspicious, check it instantly. If you're unsure about a binary, just upload it, and within seconds you'll know whether or not Protect would flag it. And here's my favorite part. When you find something suspicious, you can flag it for our Threat Labs team for human review. So that team that I just talked about at the beginning, that's the team that you can send anything that's suspicious that you have questions about to. You become part of our threat intelligence network, and your suspicious file today could potentially become protection for the entire Jamf community tomorrow. So it's not just a scanning tool, it's also a direct Dropbox for the team that builds out those Jamf Protect definitions. So let's talk a little bit about the tool. I'll give you kind of an introduction to how it works. I've got a couple of videos of it running, and then we can take it from there with questions. So here's what you're going to see when you log in. It is kind of a standalone login identity provider. TOTP is required for your login, so you're going to have some kind of auth, like token auth app in order to register for this, so just be aware of that. Now, I do want to be transparent. We are in early access. This is a controlled release, and we want to maintain performance and quality and get feedback, so we're hoping that we have some people who'd be interested in trying this out. Access is by request only, and we are going to use a third-party identity provider for right now. If there's enough interest, I think we're certainly open to using Jamf login in the future. Think of this beta as your chance to shape the future of what it becomes. So every piece of feedback helps us kind of shape something that will serve the rest of the community better. So if you want to be a part of that beta, come talk to me after this session, or find anyone from the Jamf Threat Labs booth after this talk, and we can certainly take your information down. So when you log in, you should see this disclaimer, just so that you're aware. The data will be stored in US data centers. You got to think of it as a Dropbox. When you drop it in, you're not going to be able to get it back. We will scan it, and this is going to pop up every time you log in. All right, it's quite a bit of talking. This is what the actual interface looks like. Pretty straightforward web GUI. So we've got on the left an upload interface. You can drag and drop any macOS binary or click to browse in your file system. It'll validate the type immediately. So we check the binary header to ensure it's an actual Mac OS macOS, not just something that's been renamed with a different extension. The maximum file size is 50 megabytes, which should cover most Mac OS binaries. On the top right, you're going to see that there's some quick stats. We've got recent submissions, which is just the last 3 submissions, like some of the stuff, pretty straightforward. Below that, at the very bottom, you've got a full submission history. So this is where you're going to get the results of anything that you have submitted. There is also a submission ID, so this is a unique UUID for every submission that you generate. Even if you resubmit the same binary, it is going to generate a new submission ID. The view results section will kind of show you what happened with the scan. The all submissions, hash history, upload and search tabs there, we will talk about those in subsequent slides. All right, and here we go. Let's select a macOS file for analysis and see what happens. And it's just that simple. And your results are available. So what do those results look like? Well, hopefully, this is what most of your results look like. No detections. So the system has checked the team ID, the SHA-1 hash, and scanned the binary with Yara, the Yara rules that are used in Protect, and there are no hits. You may notice that the specific engine version that it was scanned with is going to match whatever engine version is the latest version in Protect. So if there are any questions that come up about that, this will basically give you an idea of when it was hitting and what the version it was hitting at. All right, so that's pretty boring, no threats detected. Here are the additional outcomes that occur. I assume everyone here is generally familiar with these concepts. I'm going to do a very quick run through. We've got the team ID, the SHA-1 hash, and the Yara rules are the mechanisms by which Protect does prevention. So that team ID, we basically say if there's a malicious author, someone that we have associated with publishing malware, we block that team ID. So anything with that team ID might get blocked. We have specific file signatures with the SHA-1 hash. Just things that are known malicious. And then we have Yara rules, which are more general, can protect you towards the future by looking at specific elements of a binary that we know to be malicious. That can kind of protect you from malware before it's even been written, similar to how the team ID can, but it's a little bit more dynamic. All right, so this is what it looks like. If you were to get a hit on team ID, you're going to see the detection triggered, and you're going to see what threat that team ID has been associated with by Threat Labs. So we happen to know, hey, this particular team ID has published Bundler malware before. So you're going to get that answer right there for the team ID hit. You're going to see something pretty similar with the SHA-1 hash. Going to get the threat name, known to be adload. And then similar story with Yara. You are going to see that try that again. There we go. You're going to see that this triggered the atomic steel rule, and so we know that this particular threat is associated with atomic steel. Okay. So we're also going to give you the enhanced threat intelligence. So we curate a wiki already. We're basically adding that wiki information. If we happen to have a wiki entry for this threat family, it's going to come attached to the threat. If you find an add load binary, for example, you're going to get this information just automatically included in your results. Something that was fairly straightforward for us to add in, and you already should be seeing something like this in the Protect product when you see detections. So here is one of my favorite features. This is the flag for review functionality that I was talking about. So let's say you submit something, you're hoping for detections, you think it's suspicious, you want Threat Labs to take a look at it. Well, you can flag it directly with context to our team. You select whether it's a false negative that should be detected but isn't, suspicious behavior or something other. And then you provide that information in an open text box for us to take a closer look. It's not just a suggestion box, it's a direct line to those researchers. So you're actually going to submit it, and then when they take a look at it, they can actually flag it to say whether or not that has been reviewed, processed, and what has been done with that particular binary that you submitted. And so back a slide. So that Threat Labs review team, this is something we're really excited about. Them taking a look at it, analyzing it. Like if we sit down and we analyze what's happening here, we see this as an opportunity for us to cooperate, right? It's just as valuable for us to see things that are on the cusp, to analyze those things, and to extend those protections to you and to other customers. So let's talk about some of the other things. We've got the hash history. So the hash history view is going to allow you to kind of look at it from like an aggregated perspective. You're able to see submissions that you've made in the past. If you click on a single hash, like right here, it's just going to take you right to the results. If you actually go and click on something you've submitted multiple times, like right here, it'll give you the full history of the submissions that you've made, and you'll be able to look at those previous submissions. So that means if you're scanning it multiple times with different versions, you kind of have the visibility on that. Very powerful for tracking detection improvements. Very powerful for you to understand and kind of be rewarded for anything that you've submitted and asked us to review. All right, let's talk search. So the submissions are great. Maybe you don't have the binary. Maybe you saw a hash in a blog post and you want to know whether or not you're protected by it. That's where the search can come in clutch. So Search View provides instant threat intelligence lookups without needing to upload anything. So you can search either by file hash to check if something's already in our database, or by team ID, and we'll get to that in a second. And you're seeing it in action. This is kind of what it looks like when we don't find a sample versus the previous lookup when we did find a sample. It's perfect for quick investigations. Maybe someone sends you a suspicious hash via Slack. You're reviewing logs on an unknown binary. Instead of downloading and uploading the actual file, be able to know if Protect is going to block it with the hash. Now this engine version is also going to be displayed, as you can see at the bottom there, so you're going to know what that's true as of. And it essentially gives you a sort of read-only access to the protections that you would get from a hash view. Now I do want to give you some caveats here, and you can see it actually in the unknown sample. We currently do not track this hash for a comprehensive scan. Please submit Mako binary for upload. The reason for that is that we can't tell you whether or not a hash is covered by Yara if we don't have the binary ourselves. So some of these hashes, we will have the binary already in our corpus. Some of them we don't, but you may still be protected. You would have to upload to get a definitive answer, but this is a pretty good quick and dirty investigation that you're able to do. All right, so we've got Team ID, pretty similar feature. You enter the team ID, we're going to tell you whether or not we block it, and we're going to tell you what the first threat is, that family that we associated that with. We'll tell you whether or not we don't block it. There are some situations where a threat ID or team ID may not be blocked, but we would block a binary. So again, submitting is going to give you the most definitive answer as to whether or not this would be flagged. All right, so let's talk about API access. So on the profile page, you can generate up to 2 API keys. Right there, generate an API key. And this is a view once API key, so make sure to copy it, view it. This has already been deleted, so I'm not worried about showing it to you. But you do have the option to delete API keys as well, and these will expire every 4 weeks for now. For long-term access, really, this is kind of what we're looking for your feedback on the future of this. If this is something you find useful, we would come with a more robust long-term access plan depending on whether or not this is something that you find value from. So each key is going to give you full access to upload binaries, check submission status, search intelligence, and retrieve results. Most of what the web interface can do, your automation would be able to do using the API. If a key is no longer needed, or you would like to cycle that, or it has expired, as you've seen, you can delete it right in this page. And we follow the standard REST conventions with bearer tokens. Integrating it using Python, Bash, or any modern programming language should be fairly trivial. And I know what you're thinking, an API is only as good as its documentation. So we've got that for you too. You can go into the documentation, you can see the API usage, and you can even test the API out directly in console as long as you are logged in and authenticated. You can get that information back, get examples on how to use it. So here are some of the API information, as you can see. Go back to that. This is the primary one that you'll be using. It's the submissions API. Just to note, the process is it's asynchronous. So when you're using the API, you will upload the file, and you will get a submission ID back. You can check the submission ID status to see when it has completed. And then once it has completed, you can fetch the submission ID's results. And so that is the mechanism that you would use to be able to work this into any kind of automation use case that you might have. This is the this is the hash lookup. So maybe you don't have a submission ID, you want to pull it by the hash. If you've got a SHA-1 hash, you can use that. Right now, we only support SHA-1 hash. We may roll out SHA-256, but for right now, it says hash value, it's got to be SHA-1. And then we've got the search, the user information, and the flags. The search will show you the team ID results and the sample hash results. And then those flags, pretty self-explanatory as well. You can submit a flag on a binary through the API as well and annotate it and check the status of that flag. So we've also got a web portal exclusive feature. So you saw in the initial submission that we've got team ID and hash matching and Yara rules. But what happens when all three come back clean? Now normally you would get that gray little circle that says no detections, and that's it. And you're left wondering, okay, is this like, what does that mean? Is this safe? Is this suspicious? What are we looking at here? And that's where we added an AI-powered analyzer. So you've got this view right here. That's not inspiring a ton of confidence. The AI-powered analyzer is stripping key features from the macOS binary, and it's sending it to an LLM for analysis. And it's basically saying, like, hey, have a junior analyst, AI analyst, take a look at this file. We didn't detect anything on it. What does it look like? And in those cases, we're going to do our best to assign a probable type. We're going to talk about the vendor, and we are going to give it a more of a benign with a confidence level flag based off of that analysis. So it's not just not detected, it's like, hey, this looks like, some kind of very normal web browser or communication tool or something that is fairly benign for you to take a look at. So here is an example of something that came back a little bit more suspicious. We've got a pretty high confidence level on that suspiciousness. Let's try and get this to actually play. There we go. So why is it suspicious? Well, you can open it up and it's going to tell you. It's saying, hey, this looks like a malware proof of concept tool. We don't really know what it's doing exactly, but it looks super suspicious. It's not legitimate commercial application. It looks like it's stealing information basically from the end user. And it was able to do that by just looking at the different features of the binary. So this actual sample that we're using that's not detected, just to make sure everyone's aware here, this is kind of the fun part. This is a sample that was actually created by our own researchers. It's kind of a digital scarecrow. So they built something that looks absolutely terrifying to security analysis. It's doing all of this stuff. Think of it as kind of the binary equivalent of an overly suspicious person in a neighborhood who peers through windows with binoculars and takes notes on what everyone's doing. Not like technically anything illegal, but like definitely setting off every alarm bell. And the AI is basically saying, like, I don't know what this is, but it's walking like a duck, quacking like a duck, and carrying lockpicks and a balaclava, so, we probably should not be trusting this. So that's the gap between, this gap between definitely malicious and probably fine is where kind of the interesting stuff lives, and where, having this kind of analysis is like an additional data point that you can leverage. For right now, this is only available in the web portal. Don't necessarily want it to be slammed with hundreds and hundreds of thousands of requests per minute, so we're sticking with a web portal only approach on that one. Okay. So we can actually see a great example of it in action. In this particular case, I knew about a threat that we were adding, and I ran it against the AI analysis, even though it came back with no detections right before we added it. It says that it looks very suspicious and that we should not be trusting this. And all of the reasons for that. And then we'll take a look at once the protections got folded in, which of course is after. And we can see it has in fact been blocked, and it's for the exact same family that the AI analysis had classified the malware as you can see, calling it a miner, and it's saying, hey, this looks like some kind of mining service. Okay. So let's talk about use cases. And I want to be really clear here. This is early access beta, and we have rate limiting in place. We're not promising that we will handle your entire enterprise workload tomorrow. We're not really making any promises at all. What we are doing is asking you to help us figure out if this is a useful tool that you could leverage and help us understand maybe what this should become. So these are some use cases that maybe are ways that you could leverage the tool. Maybe this is something you could use for pre-deployment validation, scan binaries before pushing them out. Perhaps a developer tool vetting. When an engineer wants to, that new CLI tool from GitHub, you could validate it instead of just hoping that it's safe. Maybe some kind of incident response support or integrating it into a SIEM. So those are some of the use cases that we had in mind. But in conclusion, I wanted to ask everyone here at the end of this session whether or not this is something you'd find useful and any questions you might have. And I wanted to thank you all for coming to this presentation.
So thank you, Nick. And do you have any questions to Nick? So Nick, how can we find you if there will be any questions?
Find us at the Threat Labs booth, and if you'd like access to the tool, come talk to me right after this.
Okay, thanks.
All right, thanks everyone.